In this video, we're going to learn how to draw and use a tree diagram to solve probability questions. Take a look at this. In a factory, machines A, B and C are all producing metal rods of the same length. Machine A produces 35% of the rods, machine B produces 25% of the rods, and the rest are produced by machine C. Of their production of rods, machines A, B and C produce 3%, 6% and 5% defective rods respectively. Draw a tree diagram to represent this information. Okay, so I'll start off by saying that in the factory, the rods are produced either by machine A, B or C. So these branches represent the three different machines that could have produced it. So here is A, here is B, and here is C. And on the branches, I'll write the probability. So the probability that a rod was produced by A is 0.35. The probability that it was produced by B is 0.25. And the probability that it was produced by C is all of the rest. So these two add up to 0.6. So it must be 0.4 as the probability that it's produced by C. Okay, next, so of their production of rods, we're then told what percentage of each are defective. It says of the production of rods, machines A, B and C produce 3%, 6% and 5% defective rods respectively. So in each case, I want to branch off from each one whether or not the rods they produced are defective. So to do that, I'll have two branches coming off from A, and I'll put D for defective, and I'll put D dash for not defective. And for machine B, it's either defective or it's not defective. And for machine C, it's either defective or it's not defective. And again, I want the probabilities of each. So for machine A, it's 0.03. And therefore the probability of it not being defective is 0.97. For B, it's 0.06. Or it's 0.941 minus 0.6 of it not being defective. And then finally for C, it's 0.05 is the chance of it being defective, and it's 0.95 of it not being defective. So there's our tree diagram drawn for part A. Now for part B, we need to find the probability that a randomly selected rod is produced by machine A and is defective. Okay, crucial point then with tree diagrams is that you find probabilities by multiplying along the branches. So to find the probability it's produced by A and is defective, I multiply along the A branch and then the defective branch. So that's 0.35 multiplied by 0.03. So let's see what that is. So that's 0.0105. So there's our probability that it's produced by A and is defective. Now, what about the probability that it just is defective? Well, here we can use the additive property of the branches, that if you want to know the probability that it's defective overall, just add up the probability that it's A and defective, produced by B and it was defective, plus the probability that it's produced by C and defective. So we already know the probability that it was produced by A and it was defective. So let's just work out the probability it's produced by B and it was defective. So that's 0.25 times 0.06. And that is 0.015. And then finally, we want the probability that's produced by C and it's defective. And that is 0.02. And so the probability that it's just defective in general is all three of these added up, that plus that plus that. So we add those together and we get 0.14. Okay, so tree diagrams are not going anywhere next year, and when we look at conditional probability in the second year of the course, they're going to come back with a bit of a vengeance. But for now, that's a good challenging example of constructing an awkward tree diagram and using it to find probabilities.